Hello, hello. Hi, we're here today to talk about SCI, a protocol for safer smart contract interactions. I'm Agustin Lavarello. I work at Mimic. We have a talk in like an hour. I encourage you to go to see it. But in my free time with some friends, we developed this protocol. But before talking about like the solution and what we built, maybe let's talk about the problem first. So compromised front ends can redirect users to malicious smart contracts, leading to wallet fund losses. Basically, this is a fancy way of saying that you interact with a compromised front end, a malicious front end, you did everything correct, you enter the URL, you go to, let's say, Curve, Uniswap, but because of they had been hacked due to DNS hijacking or maybe supply chain attack, you interact with a smart contract that you weren't intended to. You sign a transaction that instead of swapping, you allow a drainer smart contract to get control of all your funds. So a little bit of the size of the problem. $300 million were lost in scams in 2023. Basically, half of that were lost due to domain hijacking, so this problem that we're talking. In 2024, 300 millions were lost only across EVM chains, and like 4 major crypto platforms were hacked. So this is a real problem. More recently, Curve was hacked due to this very problem. Their domain was hacked and compromised, so when you interacted with Curve, instead of giving permission allowance to like the Curve smart contract, it was another smart contract that basically got control of all your funds. So let's talk a little bit, now that we know it's like a real problem that users are facing, let's talk a little bit about the solution. So we introduced a decentralized verification protocol where owners can decide which smart contracts are allowed to interact with their users. So how this looks basically when the wallet or plugin or whatever you're building wants to send a transaction, it gets the domain and say, okay, it's this smart contract verified for this domain, and you talk to our smart contract that it's gonna return true or false. You have a little bit of, we build like a MetaMask snap, and you can see how it works there. Basically, it says, hey, this contract is verified, you're interacting with Rocket Pool in this chain, basically Ethereum, with this contract, and this was when the smart contract was registered in our protocol. In reality, it looks a little bit more like this. So basically, we build like a smart contract, the SCI smart contract, that it has some utils, but you can interact directly with the protocol, the registry, and the verifier. They are immutable contracts. And basically what you do is you get first you look in the registry, okay, give me the verifier for this owner, and then you look for, like if that smart contract in that chain is verified for that website, and it's gonna return basically true or false. Why we build it like that? This is a little bit more about like the registry and the verifier. Because having the verifier separate, you can create custom logic because they are smart contracts, so it depends in each use case what you want to build. So I, as a dApp owner, if I have like a really complex use case, maybe, for example, in Uniswap, you can verify like if that pool, like that smart contract, it comes from a Uniswap pool, and you can look for it on chain. So basically how it works, it's the registry, as you can see here, it has like the domain, the owner, and a pointer to the verifier. And then the verifier, we build like the public list verifier, that it's like an easy verifier where you just list, okay, all these contracts are allowed to interact with this domain. But you can build also a custom verifier, like in this example, for other more complex use cases. So how do we know who is the owner of a domain? How do we know that on chain? We build what we call registrars. Basically, registrars are smart contracts that are allowed in the registry. And these registrars, they have logic on how to know who is the owner of a domain, and we can build different rules for this. we built the ENS registrar. Basically, I don't know if you know, but you can get an ENS of your domain. So if you are the owner of that domain, ENS can check that over DNS over HTTP with some records, and then it gives you like an ENS. So we built an ENS registrar that checks if the wallet that wants to register that domain within our protocol in fact holds the ENS for that. So basically this is a look of our architecture, because ENS is on Ethereum, but we don't want every time you register basically smart contracts in your verifier, in our public list verifier. So we deploy them on Optimism, so it's cheaper. So basically we use the ENS registrar on Ethereum that we built and deploy. We use the cross-domain messenger from the superchain to talk to our registry in Optimism. Are there any other solutions out there? Yes, there are. I believe that they are not really good. For example, this one, it's if you want to stake 32 ETH, that it's a lot of money in the deposit contract, they have a pop-up saying you can go to this and we can read you out loud the address that you're gonna send the funds to, and you have to take in your MetaMask or whatever thing you are using Ledger, if that digit by digit, if that corresponds to the smart contract you are going to interact to. So it's a solution, yes, but I don't think it has good UX, especially you're sending 32 ETH or more. And then there's other solutions that maybe you can use DNS TXT records. So if you're a domain, you can put a list, okay, in my DNS, in the TXT record, these are all the contracts that are allowed to interact with my domain. You could do that, and you can verify over DNS, over HTTP. But there are some problems with this. One is that if they hijack your DNS, they can also change this list. So it's you're not adding extra security. With our solution, because this is a smart contract that has an owner, that it's a wallet, they will have to hack the DNS and your wallet to be able to change in our protocol the contracts. And also, this relies on a centralized service like Cloudflare or other centralized service that they do DNS over HTTP. To get that information, they can withhold that information. They can even change it, or they can have the downtime, because we are all on chain. You can have your own RPC. You don't have to trust us. You can check everything with your own RPC if you want, or Infura, or get a bunch of RPCs to get to consensus. So it's really flexible what you can do. And a little bit of what is the user experience using, we build a MetaMask plugin, but it's you can do a plugin in Chrome. This can be added to wallets as another measure of safeguard. So, for example, in this one, MetaMask, again, it's a little bit of the previous example. You're staking with Rocket Pool. You're going to send the transaction from this wallet to this deposit contract. I don't know even if this deposit contract is the one from Rocket Pool, and I shouldn't know. So what we did with the plugin, if you see there, it says insight from SCI, and it says if the contract is verified or not. So for stake.rocketpool.net, that contract is verified, so I know that I'm interacting with a contract that the ones that build this wants me to interact, and it's not a malicious smart contract. So I click, I see all the insights, and I can click confirm, and it's going to be good. And for example, with Curve, we tried it out when it was hacked, and it worked. Basically, you enter in the Curve's UI, and it says, hey, be careful, this contract, it's not allowed to interact with this domain. So you know that something is wrong, and you can check maybe Twitter or whatever are your sources. So this solution, it's a little bit more proactive than being reactive. Most solutions now, it's posting on Twitter, hey, we got hacked, and it's more reactive, and you are hoping that the users find out before interacting with your domain. With this, you verify it beforehand, and if you got hacked or something goes wrong, you know that your users are safe using our solution. So yeah, this is a public good. We do it in the free time. We invite like developers, auditors, whoever wants to build this and continue building it or use it to talk to me, and we hope to make crypto safer for everyone. This is the team we're for. And yeah, thank you very much. If there's any question. Any question? Okay, if you want to talk also, I'm going to be outside, so thank you.